All right, this video we're gonna try to find some inverses. Okay, so I'm gonna have a lot to do here. I'm gonna do domain and range for both original and inverse, make a table, we're gonna graph them, and we're also gonna rewrite the equation. Okay, so let's start with the table of the original. Probably the easiest way to do this is just plug it in your calculator. So let's go calculate, let's open up a graph. So we've got 3x minus 2. All right, there's what it looks like on the graph. Control T, pull up your table. And like the parent function video, we want to make a couple negatives and a couple positives with 0 in there. So we'll go -2 to +2. So -2, we've got -8. -1, we've got -5. 0, we have -2. What else do we got here? 1, 1, and then 2 is going to be 4. All right, you notice the y is increased by 3 every time. That's because of the slope. Slope is 3. All right, we'll come back into the inverse table in a second. Let's do the equation. So to find an inverse, you need to switch x and y. Like literally switch the letters. So x equals 3y minus 2. All right, now we want to solve this equation again for y to get y by itself, and then we can take a look at what that looks like. So to solve for y, we need to add 2. 3y equals x plus 2, and we divide the whole thing by 3. So y equals x plus 2 all over 3. Okay, or if you want to split it up, you don't really need to. 1/3 x plus 2/3. That's more in the mx plus b form. Makes it a little easier to graph it from that form. All right, but let's plug this in and see what we get here. So let's Control T. I'm going to get rid of the table for a second. We'll hit Tab. I'm going to go ahead and leave the original function on there, just so we can see what that looks like. And let's put this in parentheses, x. Already forgot, plus 2. All right, close those parentheses. You press Control, divided by, you can make a fraction. So divided by 3, enter. So there's our graph there. And then if we press Control T, all right, and let's see if we can find some good numbers here that are going to work for us. So I don't want to like write any of those decimals into my table. All right, let's start here. Let's start with a -8 and -2. All right, I'm picking this for a reason, and you'll see here in a second. -8, -2. All right, then the next good one's going to be -5, -1. All right, now if we keep scrolling down, we'll get -2, 0. And then we get 1, 1. And 4, 2. All right, now hopefully you kind of saw a pattern start developing there. All right, look at the two tables. Okay, just like we did in the equation, how we switched x and y and then solved it out, that's what happened in our tables here. We switched x and y. Okay, so that's what happens when you do the inverse. Switch x and y. That's really the only thing you need to remember when you're finding inverses. All right, so let's see if we can make a rough sketch of this graph. So remember, plot the y-intercept, then use your slope, rise over run. So the original one, we plot -2. Then I go up 3 over 1. Do that a couple times. All right, we're going to get a graph that looks like this. All right, and then the other one, again, like use the mx plus b form, so 2/3, that's 0.67, that's like right there. And then you go up 1 over 3. 1, 2, 3, so like that. Up 1, 1, 2, 3. All right, you get a graph that looks kind of like this. All right, we can see it better on our calculator, but this is just kind of a rough sketch for your notes. All right, and what I want you to notice is that these two are reflections of each other. and the reflection's over a specific value. So let me get rid of this table. And that function that it's reflecting over is y equals x. It's the linear parent function. So graph that there, and you see how these are reflection. This piece in the blue would reflect over this line and become this piece of the red, and same thing here. Okay, so that's what you're looking for on a graph to tell that they're inverses. They reflect over y equals x. All right, and domain and range for both of these are going to be all real numbers for both. So it's kind of hard to tell exactly what's going on here. This will be a little more interesting on a different example. But basically what I'm wanting you to see with domain and range, since they're based on x and y, is they also switch. Okay, again, you couldn't tell that on this one because they are the same domain and range. But when you get ones that are different, they will actually switch, just like the x and y in the table switched. All right, let's try one that's a quadratic here. You'll notice it says when x is greater than 0. We're going to ignore that for a moment, and then we'll kind of come back. So let's start with solving the equation this time. So x equals y squared plus 1. So I'm going to subtract 1, and I get x minus 1 equals y squared. And then you need to square root. And whenever you square root, remember you always put a plus or minus in front. So this is y equals plus or minus the square root of x minus 1. All right, let's go do our original table here. So again, I'm going to try to do the -2 to +2 on the x's. All right, so let's just clear this out. Delete 3 times, I'll do that for you. And we'll hit tab here. And x squared plus 1. And Control T, open up our table, scroll up a couple. All right, so I've got 5, 2, 1, 2, and probably 5 again, I'm guessing. Yep. So 5, 2, 1, 2, 5. All right, now that we know the pattern that's going to work, we can write this table without having to use our calculator. Just switch these. Okay, so, well, maybe I should clarify a little bit. So we don't want to rewrite like multiple x's at the same time. So like we already have 2 down here. We don't need to write it again here. So maybe just 5, 2, 1. Okay, and then that's -2, -1, 0. Okay, I'm really okay if you only do 3. If you want to fill in the rest of this, you can use your calculator. All right, but keep in mind you don't want any negative numbers because that would make this imaginary. We're not doing imaginary on this graphing part. All right, for graphing this original parabola, we can go back to calculator for that. You can see that it starts at 1 and goes up like this. Okay, we can also use these points over here that we found. So like -2, 5, -1, 2, 1, 2, 5. Get a pretty decent graph going that looks like that. All right, now the problem with this inverse, it's a plus or minus. So that would give us basically a sideways parabola. But the sideways parabola is not a function because it doesn't pass the vertical line test. Okay, so that's where this x is greater than 0 comes into play. So what this is saying is it only wants us to graph the inverse of the positive part of our original graph. So where are the x's greater than 0 on our original parabola? Well, that's only on this right side. The left side, all the x's are negative. So it only wants us to graph the inverse of this part. Okay, and what that's going to correspond to, if you think about it reflecting over y equals x, is going to be the top portion of the square root. It's going to be the positive portion of this, not the negative. Okay, so really what we're graphing as our inverse is y equals the square root of x minus 1. Just the positive portion. All right, so we can take a look in the calculator what that looks like. All right, square root of x minus 1. All right, you can see it starts right there at +1 and then just goes up like that. So only corresponding to this part. If we put in the negative square root, we would get the bottom portion, but they didn't want us to graph that part, mainly because it wouldn't be a function if we did graph it. So it starts at 1, 0. Another one is 2, positive 1. And we have 5, positive 2. And go up like that. So actually, I am going to fill in the rest of this table over here. This table, if you fill in the whole thing, it's good to show you that it's not a function. So remember, functions have to pass the vertical line test. They can't have any x values that repeat. So right there with the 2's and then again with the 5's, you have x values that repeat with different y values. And that's what you look for in the table to tell it's not a function. So basically, with that x is greater than 0 said, hey, how about you just throw out all of these and only use the ones that are positive numbers. And that's what we did to create that graph. Okay, our domain and range here, you'll actually be able to tell something. So with the original, our domain is negative infinity to positive infinity. So remember, arrows going both ways. The range, though, only goes from positive 1 up to infinity. All right, the inverse is basically going to switch that. And we can take a look. So you see that the domain starts at positive 1 and goes to positive infinity. There's no left side. So the range of the original is now the domain of the inverse. All right, and if we graph the full parabola, our original domain would be our inverse range. But since they cut us off and they only let us graph this part, it's not going to be exactly the same. This one goes from 0 and then it goes up to infinity. So 0 to infinity on that one. All right, so I think we've had enough of the graphing and tables. I think you know what's going on there. I do want to do a couple more of just solving the equation portion of it, because that's kind of a big concept with finding these inverse, being able to rewrite the equation. All right, so we switch the x and y. So that's going to be x equals negative 2 over y minus 5. Okay, anytime you have what you're solving for in the denominator, your first order of business is to get it out of the denominator. We can't solve for y if it's in the bottom of a fraction. So I'm going to start by just multiplying by this denominator on both sides to cancel it out. Okay, going to happen over here. All right, so that'll cancel, and this gives me x times y minus 5 equals negative 2. Now I can divide by x. Y minus 5 equals negative 2 over x, and then finally I can just add the 5 over here. So y equals negative 2 over x plus 5. All right, let's do one with the radical in it. Okay, so x equals the square root of y plus 2 minus 4. Okay, so I need to add 4. X plus 4 equals the square root of y plus 2. All right, then we need to square both sides. Now this side has 2 terms, so you got to put it in parentheses and square it. And what does that mean? FOIL. Okay, you got to do FOIL window pane to multiply that together. You can't just say it's x squared plus 16. Okay, so after foiling that out, you should get x squared plus 8x plus 16 equals y plus 2. And then we just need to subtract the 2, and we'll get our inverse. Y equals x squared plus 8x plus 14. All right, and try plugging the original and this into your calculator. Same thing with this one, and seeing how that reflection works, and then taking a look at the table and seeing how the switching of the x and y works on those as well.